Hello everyone, welcome to a new video on electric vehicle technologies. I'm very glad to meet you all in this new video series. So in this video series, previously we have discussed two topics, one in which we have discussed about the history and evolution of electric vehicles, and then we have discussed about the benefits and challenges of EV. Now we are going to discuss about an interesting topic, which is the hybrid electric vehicles. So in today's topic, we are going to, previously we have discussed about electric vehicle definition, types of EVs, components, advantages, challenges and all. Now we are going to discuss about one of the main type, which is the hybrid electric vehicles. Why we need an HEV? So let's empathize on that. First, there is a range anxiety among the users, and also a big challenge for EV adoption is the charging infrastructure, and the efficiency, the compact design, ease of parking, these are all plays a vital role in EV adoption. And finally, why we need a EV is that a lot of CO2 emissions and sustainable manufacturing. So these are making the current vehicle users to urge for an alternative. While the regular internal combustion engines has lot of advantages, yet it lacks few advantages, which is like it is very costlier and it is not environmentally friendly, which is not eco-friendly. It emits a lot of CO2 emissions, which is big threat to the planet, and very costlier. So in order to balance that high upfront costs, people are now moving for electric vehicles, which is not fully electric vehicles, a combination of both, which is the hybrid electric vehicle. A hybrid electric vehicle offers long-term savings with environmental benefits also. It ensures a good mileage, speed range, and also it has adequate charging access also. And so for all those empathies that we have discussed previously, the solution is the hybrid electric vehicle. What is hybrid electric vehicle? It is a combination of internal combustion engine with an electric propulsion systems. The main aim is to improve fuel efficiency and to reduce CO2 emissions. So the key components of an hybrid electric vehicle is an IC engine, an electric motor, a battery pack, power electronic equipments, and the powertrains. So hybrid electric vehicle is a combination of both. It has the regular IC engine structure with a parallel electric motor plus battery backup setup, which offers power then and there. So let's discuss the working principle. Basically, the hybrid electric vehicle is of three types, which is series hybrid, parallel hybrid, and series parallel hybrid. In series hybrid, the IC engines generate electricity to power the motor. In parallel hybrid, both IC engines and electric motors directly drive the wheel. But in series parallel, the combination of both series and parallel configurations will be available. So this is the main working principle and the power flow of electric HEVs. So when it operates in electric only mode, the battery, the power electronic converter, and the motor and transmission powertrains will work, which means the power is fed from the battery pack through the power electronic converter. It is fed to the motor, and the motor drives the vehicle. In hybrid mode, both battery as well as the internal combustion engines both drives the vehicles. During battery charging, the engine drives the motor, and the power from the motor will be the power, the back EMF, the EMF which is being generated from the motor is being tapped by the power electronic converter and is used for battery charging. While regenerative braking, the motor will operate in a generator mode, which makes the power electronic converter to convert that power into DC and thereby storing the battery. Now let's discuss in detail about the series HEV drivetrain. A series HEV drivetrain has two set of motor and converters. We have a generator and converter which is connected to the engine. Then we have a battery and the converter which is connected to the transmission system. So a series hybrid is one in which only one energy converter can provide propulsion power. So that the heat engine or IC engine acts as the prime mover which drives the entire drivetrain. In parallel HEVs, either one or more energy source can provide propulsion power. Here, the IC engine as well as the electric motor are configured parallelly, thereby both can power the transmission. In series parallel HEV drivetrain, a combination of series and parallel configurations are being used, which means that the advantages of both previously discussed configurations are being incorporated in this kind of HEV drivetrain. So here the heat engine also charges the battery. The recently available Toyota Prius is an example of such hybrid. So this is a simple outlook of the classification of HEVs that we have discussed so far. So here in the simple slide, I have incorporated all the basic block diagrams in a single slide. What is the benefit of HEV? Why we need HEVs? The first is the fuel efficiency. Instead of depending completely on fossil fuels, if we have a battery pack, we can reduce the dependency on fossil fuels, and also we can, which makes it fuel efficient, right? So we have regenerative braking, and also use of battery power can make fuel dependency quite lower, and also it leads to lower CO2 emissions. And also, since we have both power, we can make it more increased performance, which means that enhanced acceleration with electric motor assist. Now let's discuss about the challenges and limitations. The main challenge for hybrid electric vehicle is the cost. It has high upfront cost compared to other conventional vehicles, and also the weight, since it has both IC as well as the battery and electric motors. Additional components add more weight to the vehicle, and also the regular challenge that any EV can face is battery life and disposals. So it is a big concern for EV. So future trend is that more advancement in battery technology is being expected, which makes higher energy density and faster charging, and also the integration of renewable energy like solar and wind power integrations for charging stations, and EV is making a completely autonomous and connected vehicles, so through intelligent systems. Now let's discuss about the applications. HEVs are more used in passenger cars, buses, trucks, ships, submarines, and in hybrid propulsion systems like in aerospace. So in this video we have discussed about what is an HEV, why we need an HEV, and what is the different types of HEVs, and also we have discussed about each type's architecture, and finally we have discussed about its advantages, challenges, and applications. Let's have a quick knowledge test on HEV, which is of the following is not typically considered as an advantage of HEV? Improved fuel efficiency, reduced emission, significantly lower purchase price than conventional cars, and extended driving range compared to battery. The answer is C. The upfront cost of HEV is high. The question is which is not considered not a advantage of HEV. So it is C. So hope in this video we have discussed about HEVs in detail. In the next video series we'll discuss more EV topics in detail. Thank you. Thanks for listening.